This talk is based on ideas that I've had over the last couple of weeks, and it's based on a conclusion I came to yesterday or the day before. So take it with a grain of salt, but I'm going to try and make an argument here. So how to organize your metrics. Why would you want to organize metrics, I guess, is one question. The thing is, once you have thousands or tens of thousands or hundreds of thousands or millions of different metrics and series that you're tracking, organization becomes necessary, right? And it's trivial to get to a point where you have hundreds of thousands of metrics. It's really easy. You put collectE on all your servers, and boom, there you go, thousands. So really, when I'm talking about organizing metrics, why I think it's important, it's around two different dimensions. One is discovery, which is what metrics do I have? What measurements am I taking? And then the other is, once I know what I have, how can I take those and combine them together? You know, a lot of times you'll show like a single series, but a lot of times you want to combine them together, compute quantiles or sums or all sorts of other things. So this is obviously very familiar to most of you, graphite. Graphite uses a hierarchical scheme. At least this is my claim, that it's hierarchical. And this is largely an artifact of the implementation details behind graphite. Series are basically single files that are essentially round-robin databases that are organized in a directory structure on your disk. And the metadata that you have around the series is encoded in the metric names. So OpenTSDB takes another approach. Most people think OpenTSDB is tagged. And it certainly looks that way. But if you examine it, so here we have some OpenTSDB data. At the top, you have the name of whatever it is you're measuring. And then you have the tags. So I would argue that OpenTSDB is actually a single-level hierarchy plus tags within that level. So the hierarchy is the names, and then you have the tags. And the metadata is encoded in the series names, but also in the tags. So how many of you know about InfluxDB before this event? OK. So I decided not to give an intro talk because I thought everybody would be bored of that by now. So if you don't know about InfluxDB, go to influxdb.com and check out the Get Started guide. It's pretty cool, I think. Anyway, so this is just as a quick intro, at least, this is what data looks like in InfluxDB. OK, so I represent it as JSON because that's how we write it in, and that's how we read it out. Here you have a name for the series. Name can have any character in it. It's not restricted, but the names don't have restrictions like in Graphite. You have a set of columns. Time is a built-in column, then whatever you want. The column values can be strings, booleans, integers, doubles. That's it. Time here, that looks like a second epoch, but you can actually store timestamps up to microsecond scale. Under the hood, that's how it stores it. And the other thing to note is that you can write in the time. You can specify the time. With Graphite and RRD, those are round-robin databases. So there's a built-in assumption that you have a data point, say, once every 10 seconds or once a minute. With InfluxDB, you can store that kind of data, which is regular time series data. But you can also store irregular data, which is basically event-style data. The structure of it is flat. So this is a command we have in the query language. You can say list series. It'll just output a list of all the names that you're tracking in InfluxDB. You can add a regex to that. So in this example, say, as part of the series name, we have the data center and the data center that it's running in. So if we want to do a query where we say, OK, let's look at the 90th percentile of CPU weight across all the hosts in the US West data center. We're doing a merge on that, whatever, all that for the last 4 hours in buckets. Yeah, thank you. So the problem is This doesn't really scale that well once you get to a point where you have millions of series. We do this regex thing on the fly, so we have all the series names in memory, and we just scan through them to see what matches. And unfortunately, once you get up to, I don't know, probably over about 300,000 series, it gets painfully slow. So another way you can do it, because InfluxDB schema is fairly flexible. You can change the way you store things. So instead, say we have the series called CPU weight, and we store the data center as a column value. So here we're just saying, OK, 90th percentile, 10-minute buckets for the last 4 hours for data center US West. And the problem is that doesn't scale very well when we have thousands of hosts, because the way we store the data, we actually have to range scan through all those values. So when it comes to organizing this stuff, I feel like we have to pick a method. We have to choose something. So the question is, do we go with hierarchies or do we go with tags? Now, I've talked to a number of people about hierarchies versus tags. And the real question is this a religious debate? Like this one. I.e., it is a debate that can't be solved. Or is it a scientific debate? By the way, I don't know what this is. This is Neil deGrasse Tyson, but that was, I did a Google Images search and scientific debate. That came up. I was like, OK, that'll do for my slide. So like this, right? These are things that have a clear, testable answer. These, as computer scientists, these are the things that we like. I think tags versus hierarchies is probably a bit of both. But I will make this claim. So bear with me on my pseudo-scientific religious debate about why tags are vastly superior over hierarchies. So the first thing, when I'm thinking about how to organize metrics data and time series data, really it comes down to what questions can you ask? What questions can you ask about your data? Like, what sensors do I have? This could be CPU, network in, out, Redis key counts. Basically, what things are you measuring? For OpenTSDB, that's names, right? That's where you keep that, right? You look at the different names you have, and that's what you have. So it looks like this. So for, wait, go back one. Back. Yes, OK, sorry. Forward. I'm used to having a presenter display. Forward, forward, forward. All right, graphite. If you want to answer the question, generally speaking, depending on how you structure your metric names in graphite, if you want to answer the question of what sensors do I have, you essentially have to traverse the hierarchy. So basically, here we have some examples. So say we have app. So we're essentially going whatever the thing is, then the value, then the thing, then the value. So app, the name, data center name, host, the host name, and then finally, what is the thing you're measuring? Now, if you just get a list of metric names, like all of them, like flat, right, like this, then you can just look at the last part of each one. But again, if you have millions of metrics, you're going to be very sad when you try to answer this question. So essentially, you have to like traverse that entire hierarchy to get down to the name. Right, sensor names at the end. So another question that I think is interesting is, what values do I have on some dimension, right? And the dimension could be like hosts, data centers, applications, all sorts of stuff. So OpenTSDB, essentially you traverse one level, which is the name, and then you ask that about the tags. So basically we say, oh, we have a series called Redis connections, and another series called response times.90. In Graphite, you have to find your spot in the tree. And the truth is, like, depending on how you structured things, maybe things will be at the same level of the tree, but maybe they won't. In this case, say what data center, everything's at the same level. So another one that I would want to ask is like, show me all time series for something, right? A great example is for services, right? Show me all the time series for the Redis services, or show me all the time series for MySQL, right? Using that, you could quickly build an entire dashboard that just shows you everything for some particular service or some particular host. And then finally, there's the computations themselves, right? This is, give me percentiles across this collection of hosts together, or data centers or whatever, or this service. So the pure tagging approach, which I don't think OpenTSDB takes, and this is, as of a day or two ago, the approach that I'm advocating for, is this. It looks like this. So essentially you have this, and then you would have some sort of value, right? It would just be like a double. One nice thing, you have readable names. There's no need to constrain yourself by what you can represent on your file system, like in Graphite. It's queryable. So here we say, which hosts, wait, what is this? Oh yes, which hosts have Redis connections, right? So that's the name of the thing, and we just say, okay, host is another dimension on it. Or, for example, what names or sensors do I have for my application, right? What am I tracking inside a certain app? Or, in our case, since you can store data at any precision, it's not fixed. You don't have to say ahead of time, like, okay, we're going to have these metrics that are in 10 seconds and these that are rolled up at a minute and all this other stuff. We let you store it however you want. So you could have precision as a tag or field that describes the metric. So you can say, oh, what metrics do I have at the 1 hour precision level? And finally, if we want to do computation on this, this is just like a sketch of an idea. Like, this isn't actually real. You can't do this right now, so don't get too excited. But basically, this is like, OK, let's get the 90th percentile of CPU weight across all hosts in the US West data center in 10-minute buckets for the last 6 hours, right? So we just use the set of tags to describe the collection of series that we're going to like aggregate together. And you can also create hierarchies on the fly based on this like loose tagging structure, right? What tags co-occur with other tags? And there's a model for this kind of setup for organizing data in this way. And I say the model is like faceted search, right? If you go to Kayak and you do search and you see like different things, you can see, oh, like British Airways has this number of flights for this or whatever. So this, part of this is given these two tag names, host and data center, what other tags are there? What time series exist that have other tags with them? And then this is like the faceted search look, right? Like, so say we have data center equals US West, then we see these other potential tag values and say, okay, we have 2,153 series that have a name, 256 hosts, 20 services, 10 different levels of precision, and say 4 applications. So what you can do if you're drilling down is you can say, oh, well, I know what the next thing I want is. I'll select application because that's going to eliminate a lot of data out of, a lot of potential time series out of this, right? The things with the lowest cardinality are the ones that have the potential to split the search space up as much as possible. The key around this idea is that we need to be able to add dimensions or add tags on the fly. We don't want to have to define them up front and have it be fixed. And we also have to support a high cardinality for the number of tags that you can use. So people who use OpenTSDB are familiar with the problem where if you add too many tags, you end up like creating hotspots in your data, in your database. So they say like don't use more than like 6 or 7 tags. I would say like pure tagging gives you so much more power over how you slice and dice your metrics and how you can search over them that hierarchies just don't give you. But the problem with all of this, with tags in general, and that's certainly the problem that the OpenTSDB team found, was that it's a combinatorial problem, right? The more tags you have, the more ways you have to index your data. So you have to be smart about it. Otherwise, you're just going to explode the size of your database. So in my mind, the way to get around this is to give people the tools to define how they want their data indexed. Let them write it in however they want. And if they run a query where it has to churn over a bunch of data and it's horribly inefficient, as long as they can say, oh, that's a query that I'm going to be running frequently, so I want to index that so that it's fast, then I think we'll be good. The question is, can it work? Well, this is one of the many things we're working on at InfluxDB, and I would love to talk to all of you after this and get feedback and stuff like that. Thank you.